Okay, this is the P2 paper from January 2021. Question number 6, which, as we can see by looking at it, is trig identities and trig equations. So the first thing we've got to do is to try and show that this equation here can also be written in this format. The fact that sine theta is not equal to a half is because we can't be divided by 0 there, so don't need to worry about that too much. Okay, let's have a bit of a look at it before we get started then. We can see that the final equation doesn't have any cos in it at all. So what I'm thinking before I get started is hopefully at some stage I'll get some sine squareds, I'll get some cos squareds, and then cos squareds is 1 minus sine squared. So that's how I'm going to probably get rid of that cos one there. If you're not sure where to start, which I wouldn't blame you over, let's have a look at the function. The first thing that I would do then, if it wasn't immediately obvious what to do, so 2 sine theta minus 1 is equal to 5 tan theta. Now you could just change this straight away to sine over cos, one of our identities, but what I'd probably do first of all is to just at least get rid of the fraction. So multiply everything by 2 sine theta minus 1. So we get 3 sine theta cos theta is equal to 5 tan theta times 2 sine theta minus 1. And now I'm going to change tan theta to sine over cos. So I'm going to get 3 sine theta cos theta is equal to 5 sine theta over cos theta 2 sine theta minus 1. And now I'm beginning to get signs of what I want. If I multiply by cos there, I'll get a cos squared. A cos squared can change to 1 minus sine squared. And then by multiplying everything out, I'll be pretty confident that we'll get somewhere close to our answer here. So next step is to multiply out by the cos. So I'm going to get 3 sine theta cos squared theta equals, let's just leave everything else the same. We don't need to do it in too many quick steps here. You might be taking some shortcuts. Remember, it's a proof, so you've got to show as many lines as possible when we're going through and doing this. So now I'm going to multiply out the cos squared. I'm going to call that 1 minus sine squared, and I'll multiply out the right-hand side with the bracket. So I'm going to get 3 sine theta, 1 minus sine squared there, is equal to 5, no it isn't, is equal to 5 sine theta times 2 sine theta is 10 sine squared theta, and then 5 sine theta times minus 1 is minus 5 sine theta. Let's multiply out the left-hand bracket now. 3 sine theta minus 3 sine cubed theta is equal to 10 sine squared theta minus 5 sine theta. And now get it all equal to 0. Let's get the cubed over to that side, I think. And also, in terms of my handwriting, let's just tidy up that. It is important that you're relatively clear with all your writing down of everything. Okay, so yeah, tidying that all up, it's going to come to 3 sine cubed. It's going to be plus 10 sine squared. And then the minus 5 will be minus another 3. So that's minus 8 sine theta equals 0. Let's go and have a look. Yeah, thank goodness. Okay, so we've got what we wanted for the first part there. Just a quick reminder then, when I was saying cos squared is 1 minus sine squared, I think you ought to know, obviously the actual identity is sine squared plus cos squared equals 1, but I think it's really important that you actually also know cos squared is 1 minus sine squared, or sine squared is 1 minus cos squared. We use it all the time. That should be no difficulty to you at all. Okay, let's have a look at part B. Part B says, okay, let's see if we can solve an equation now. X is going to be between minus pi over 4 and pi over 4. So we're working in radians. Change the calculator to radians. Solve the equation. And then if we look at this one and we compare it to that one, it's pretty much identical. We just need to replace theta with 2x. Okay? So if we're going to replace theta with 2x and see what we get there, what I'll do is instead of solving that equation, I'll be solving this equation here. So in order to do that, what I always do with these ones, let's not gloss over it, is look at that part though. If we've got that x is between pi over 4 and minus pi over 4, then 2x will be between double that. So I do it straight away because otherwise I'm liable to forget as I'm going through the work here. So pi over 4 and minus pi over 4, I'm on the lookout for this, that it's a double angle here. It's 2x, so it's 2 pi over 4, which is pi over 2. It's minus 2 pi over 4, which is minus pi over 2. So when I've got my range of values then, for my answers, I'll need to be aware of that going through. Okay, so we had 3 sine 2x cos 2x all over 2 sine 2x minus 1 is equal to 5 tan 2x. And using part A, then we can say that's the same as the 3 sine cubed one. So it's the same as 3 sine cubed, 2x though, 3 sine cubed 2x plus 10 sine squared 2x, in brackets like makes it any clearer to you, minus 8 sine 2x is equal to 0. Right, so it's a cubic. I don't like trying to solve cubics, but I can see that sine 2x is in all of them. So if I factorise and take sine 2x out, I get left with 3 sine squared 2x plus 10 sine 2x minus 8 is equal to 0. Now, if you want to change this and just call it a quadratic 3u squared plus 10u minus 8 for that part there to be able to factorise it, you can do factorise it and then put it back in. I'm saying factorise, I'm assuming that this would factorise. It'd be very unusual at this stage to have that needing to use a quadratic formula. It just doesn't fit with the rest of the work here. So I think I've got sine 2x and then factorising that bit. Say if you needed to go away and do it slightly simpler using a u or a y to be able to make this factorising that much easier for you to understand, then by all means go ahead and do that. If you can't factorise a quadratic where you've got the number here being bigger than 1, go and have a look on my channel. There's quite a bit of description of how to do that sort of factorisation. So we're ending up with that equals 0, which is going to give me my 3 possibilities. So sine 2x equals 0, 3 sine 2x minus 2 equals 0, or sine 2x plus 4 equals 0. Now this is a fairly standard sort of thing that we're going to be getting when we get to this next line. I'm going to get sine 2x equals 0, which I can work out from the curve. I'll do that in a second for you. I'm going to get sine 2x equals 2/3. Sorry, slow down, equals 2/3. And I'm going to get sine 2x equals minus 4. They really go to type here. That one there are no solutions. So I didn't expect to do the same bit of work here 3 times for these different things. That wouldn't make any sense for the examiner. If I'm solving where sine 2x equals 0, I do that from what the graph looks like. Okay, so I don't use the cast diagram for this one. If sine 2x is equal to 0, sine looks like that. So it would be 0 there, there, and there. Well, the only one that fits in the range of values we've got is x equals 0. For sine 2x equals 2/3, I would now use the cast diagram. So for the cast diagram, I'm going to get a value here, all sine, tan, and cos. So I'll get a value there where sine 2x equals 2/3, but I'll also get a value in the second quadrant. So there's going to be 2 answers that are possible for that one. However, our values, let's go back now and remind ourselves, our values are from pi over 2 to minus pi over 2. So actually, no, there's only going to be one. There's only actually going to be that one that fits into the range. So if we do inverse sine of 2/3, we're going to get that 2x equals inverse sine of that. Remembering, guys, to have it in radians, okay? That works out to be 0.7297. So x is actually going to work out to be half of that, 0.365. And as we say, within the range of values, that's the only one that will count. So we get that as our final solution. X is equal to 0, x is equal to 0.365, or no solutions. Okay, nice question that. Hopefully all the techniques there involved and all the methods make sense to you.